Hello and welcome to the second video, which is all about understanding your instrument. So in the previous video, we mentioned the different types of measurement parameters and instruments that cater to the different measurement requirements. No matter which measurement you wish to carry out, you will have to obtain readings of voltage and current in the correct way and at the correct locations. If you are doing voltage power quality only, then you will need to measure the bus voltage, and this becomes a lot simpler. Here's a photo of a typical instrument, the terminals of a typical instrument. Now, your instrument will be equipped with three-phase voltages and current inputs. The voltages will be A, B, C, and neutral, and the currents will be A, B, C. So on this instrument, we have neutral, and we have phase A, B, C, and here we have currents phase A, B, and C. In South Africa, we normally have phase colors red, white, and blue, and here red, white, and blue. But it depends on your country and what color scheme your country uses. So some instruments allow measurement of multiple feeders on a common bus, and in those cases, the common bus will have the same voltage. There is one set of voltage measurements and 2, 3, or 4 or more sets of current inputs. Note that each set would be three-phase. So if you're measuring on a common bus, you'd have one of these voltage, and you might have 2 to 4 of these. Or it could be more, it could be less, it could be 3. It depends on the type of instrument that you are using. But remember, it has to be on a common bus. Then only will all your power information be the same. Now, single-phase instruments are not very common, but are available and are more likely to be used for measuring house loads and consumption. For voltage measurements on low-voltage systems, you would connect your voltage clips to either the circuit breaker terminals, as you see in this picture, or you could connect them onto the voltmeter. So your voltmeter would usually have a selector switch at the back, and you could connect onto each of the phase voltages on that selector switch, or directly onto the bus bars of the relevant phase. So here you see we have the bus bars coming out of the circuit breaker, and they've got a little bolt and nut connection for all the outgoing feeders or all the outgoing circuits, and you could connect onto that. Now, we will talk about safety later when we get to the actual connections and measurements, as it is one of the most important aspects of conducting a successful measurement. Now, here we have photos of typical type of voltage clips. So depending on where you are able to connect your voltage leads to, there are various types of clips that can be used. The standard crocodile or alligator clips are useful for connecting to bus bars, and in some cases to circuit breaker terminal bolts on large circuit breakers. So these crocodile or alligator clips, it depends where in the world you come from. In South Africa we call them crocodile, and in USA you would probably call them alligator. So you would connect these, and then they've got their leads, and these leads go directly into the instrument. Okay, and then you have the micro clips that can be used when connecting to live sections that are small or difficult to get to. So these are micro clips, and you don't usually get these with the instrument. They usually are off-the-shelf aftermarket accessories that you would buy from an electronics or electrical accessory store. Now, if you have a look at this photo, this example shows the point or the type of point that you could connect the micro clips to. These types of connection points are rare, but you should get the idea. If you have a look at this photo, you've got these little exposed bus bar sections. Now, a standard crocodile or alligator clip is not going to go around there. So you could use a micro clip to connect there, or let's assume this feeder here has got a little bit of exposed insulation, then you could connect it onto there. But before you do any connections, make sure that these terminals are tight so that your wire does not come out and cause a loss of supply on one of the circuits. Now, if you have a look at this photo alongside here, this is one of the examples I've found several times in my measurement experience. And what happens here is there's a spare three-phase circuit breaker in the panel, and it's not being used for anything, but it does have supply coming in at the top of the breaker. So all I do is I take my banana plugs and I connect them into the bottom terminals, tighten the terminals and switch on, and there I've got three-phase voltages being measured. It's a good secure connection and very safe. The current connections would have a current clip-on CT or current transformer on the end of each phase cable. These are the CTs that would have to be placed around the relevant phase cable to be measured. The CT rating is crucial here, and one needs to ensure that the maximum current that the CT can handle is greater than or equal to the phase cable being measured. For this, one would look at the circuit breaker size of the feeder or the cable size. So, for a 250 amp circuit breaker, you would have to use a CT with at least 250 amp rating. So, you have a CT here and it has a rating of 250 amp, and it's got to be greater than or equal to 250 amp if you are measuring a 250 amp feeder breaker. If it's not, then you risk saturating. If it's less than that and the current does exceed 250 amp, you risk saturating the CT and resulting in incorrect current readings. So now this is the primary side of the current transformer. Now, depending on the type of instrument you are using, the secondary of the current transformer may be 5 amps, or the CT may be a transducer which outputs a certain voltage as a secondary current. I use an instrument that has a 5 amp 1 volt transducer. So this transducer is meant to clip onto an existing panel CT and uses the secondary current of the CT, the 5 amp side, and converts that to 1 volt. The instrument software then interprets the voltage received and displays it back as a current. So here's a photo of the typical transducer that I use, which is 5 amp 1 volt. So what happens is I'm measuring a 250 amp to 5 amp feeder. So I clip this onto the 5 amp side, which is normally the small wire, 2.5 millimeters squared or whatever AWG. I'm not sure what's the gauge rating for 2.5 millimeters squared. And that in turn will output 1 volt. And then my instrument software then converts this back to 5 amp. Now with 250 to 5, my CT ratio is 50 amp. So when I export my data into Excel, then I would take the output of the 5 amp side and I would multiply it by 50. So if I'm measuring 3 amps, then I'm getting 150 amps on the actual feeder. Now panel CTs are mostly primary current 5 amp, such as 500 to 5. In some cases, you get primary current of 1 amp. This photo here is a 1600 to 5 amp CT, and it's connected onto the low voltage bus bar of the feeder. So it will either be on a bus bar or on the cable coming out of the main circuit breaker. We will touch on the instrument configuration sections later when discussing the installation and recording. These will differ between instruments, but we will cover some of the basic settings to look for. So, what have we covered here now? We have covered instrument connection terminals, the ways to connect voltage leads and the type of clips that you can use, and the ways to connect current clamps and the type of CTs or current transformers that you will use. Now, in the next video, we'll look at the typical measurement locations, the measurement parameters and instrument configurations, the on-site connections and safety, the instrument configuration on-site, and the reporting. Thank you, and I'll see you in the next video.